So this is a seminar on instrumental variables. And this is a method we use to estimate the effect of some kind of cause. And the magic of this method, as I tried to explain in the lecture, is that we don't need all the confounding variables. We only need one variable that is related to the cause and not directly related to the outcome. And if you can find a variable like that, then we can identify the causal effect. In this case, we're going to use the example of whether financial aid will help children finish school. So if you get financial aid, does that increase your probability that you will actually finish school? And we're going to say that's 8th grade. Okay. And that's one example we could use. We could use other examples. For instance, in the lecture we used, does education increase your salary? And then you have to find an instrument. And the instrument in that case was the month you were born, because that was related to the education, but it should not be related to income directly. In this case, it's financial aid. And we have the same problem, of course, because financial aid, those people, we could just take the average and say, those people who receive financial aid, they do not finish school. So it seems to be bad to get financial aid then. No, it's the fact that the group, those students who actually get financial aid, they're probably not the same kind of people who do not get financial aid. And because they have more problems, they will probably not finish school to the same extent. But that's because they have more problems. It's not because they receive financial aid. So we have to kind of find, maybe you don't have all those background variables. So we need to find a method so we can estimate or isolate the effect of financial aid on the probability of finishing school. Now, to do this, I'm going to use pandas. That's the package where we have the data. And stats models, you're familiar with that. That's going to do the regression for us. And we're going to use some packages to create graphs. Seaborn is just a package to create graphs as well. So we're going to do that. And this one, you may not have to do this anymore. We used to do that in the old days to say that it's OK to create graphs. Now, this data, this will have the following variables. One variable will say whether the student finished 8th grade. So that's important. They finished 8th grade. Another is whether they used financial aid or not. And we have age, and we have the gender. And then we have this key variable here, whether they won a lottery, because this is what's going to allow us to identify the causal effect. In this data, we have some people who actually got financial aid because they won a lottery. So they had an experiment basically where they offered financial aid to some people who were lucky in the lottery. Okay. We're going to use this as an instrument, whether they won the lottery. Now, so we have to read the data, and I put it online here so you can just read it, and let's have a look at it right away. Okay, that's the most important thing. Let's take this away, and we're going to do some descriptive statistics. And we're going to look at, okay, so we have the ID of a person here. This is whether the person won the lottery, if it's male, age, if they finished 8th grade, and whether they used financial aid or not. Okay, so we have all the key variables here. Let's also, we can just look at the columns. If you remember, we can do that. So that's all the variables again. And we don't need to put the columns in lowercase because they're already in lowercase. So I'm going to take away this. You could just do a descriptive statistics just to see some averages. For instance, here you can see how many variables there are, 1,171 ID variables. And you can see the mean, whether they won the lottery or not, and how many are male, about 50% are male. And so just this command, take the data frame and describe all the variables. It's going to give you some information that it might be useful. Now, let's just start by doing a very basic analysis. What is the difference between the group that got financial aid and did not get financial aid? And to do that, we do the following. Take the data frame. And we're going to split the data frame now, right? We're going to split it in those who got financial aid and those who did not get financial aid. So we do that by taking the data frame and group by. That's splitting the data into groups based on whether they got financial aid or not. After splitting the data, in every group, we're going to focus on this variable, whether they finished. What do we want to do with this variable? We're going to take the mean of the variable, right? And after taking the mean, we could just stop there, but I want to plot the mean also. So that's why I said plot, and you can do it this way, kind is equal to bar. So let's see what happens then. This is what we get. those who got financial aid, or those who used financial aid compared to those who did not use financial aid. And in this case, it seems to be the case that those who used financial aid, they finished school to the percentage of those was a higher percentage who actually finished school or finished 8th grade in this case. But this is for those who used financial aid, okay? So there could be some people who actually were offered financial aid, but they said, no, thank you, I'm not going to take it. And there could be some people who, of course, they would finish anyway. So you can't say that this is the effect of financial aid, because even if they did not get financial aid, maybe they would have finished anyway. So we just don't know, okay? But we can just look at the data, and now we're going to try to isolate the effect of financial aid. And the way we do that is, again, by using these method variables. We could do some more differences there, of course. You could just do the percentage difference instead of the absolute here. 13% difference between the groups. So I took the mean, and then you added diff to see the difference between those two means. You could just add percentage change if that's what you want to look at instead of the absolute difference. So it's quite a big percentage difference. Okay, so let's just use, again, the basic start with a normal regression, ordinary least squares. The model then is whether they finished 8th grade, and we have whether they used financial aid, we have male, and we have the age. So that's going to affect this. We run this model, and we see that, yes, financial aid had a positive increase to the probability here. It was not really, yes. So just notice, by the way, that in this case, I used a logit instead of an ordinary least, sorry, I said ordinary least square. I should have said, because whether you finish 8th grade, it's a 0-1 variable. So I use a logit variable because that's going to constrain the variable to be between 0 and 1. So what we get is a probability, basically. The probability that you're going to finish 8th grade. Now, the key thing here is this way of doing it is not perfect because we're missing. We have a couple of variables. We have male and age, but there's probably a lot of variables here that are between whether they use financial aid and whether they finish school, and whether they get financial aid and whether they finish school. So there's a lot of variables we should have included here. We don't have those variables. We can't do it, but we can still estimate the causal effect. And we're going to do that by using the lottery. Okay, so first of all, let's check the first assumption. Is there a correlation between if you won the lottery and if you used financial aid? Yes, there seems to be a decent correlation, 0.68. Now we have to model, and that's the first step when you do instrumental variables. So we take this variable that we're interested in, whether they use financial aid, and we're going to predict this variable based on whether they won the lottery and also the other characteristics we know, whether they're gender and age. But this is the key. We're modeling the variable we're interested in using the instrument. Okay. So we did the analysis, and there seems to be a correlation. We already know that. So now we can predict whether you use financial aid based on all the variables you have, like based on the results we got in the stage 1. So whether you won the lottery, whether you're male, and what age you are, we can find a probability that you will actually use financial aid, given all those variables. So that's what I'm doing here. I'm taking the results from the first model and predicting. That's going to give me the probability that they will actually use financial aid. I'm putting that into a variable in the data frame called data frame predicted use of financial aid. So that's the first step. Now I found a predicted value. The second step is just using this predicted value instead of using the variable we had, which was whether they actually used financial aid. Now we can use the predicted value instead. So the model is, again, the outcome is whether they finished 8th grade. Now, instead of saying whether they used financial aid, we're going to use the variable we just created, the predicted use of financial aid. And then we also include the confounding variables or that we already have. But this is the key, right? We're replacing, we used to have, the variable used to be whether they used financial aid, now it's predicted use of financial aid. That's the whole thing about instrumental variables. We're just taking the variable that used to be here and replacing it by its predicted value. And the predicted value is based on a regression that we just did. So let's run this. Now we see we get 0.77. So that indicates that financial aid has a bigger effect than what you would have if you just run the normal regression. Let's go back here and say financial aid, 0.57 here, right? So if you had forgotten about this and thought, oh, this basically using the basic result here, this is the effect of financial aid. No, it's actually bigger than this. Okay, and this is what we discovered when we used an instrument that can identify the causal effect in an unbiased way. Of course, we also assume that this instrument, the lottery, in itself does not affect whether you finished 8th grade or not. So that's an additional assumption. In this case, it seems reasonable because a lottery should not affect whether you finish something, except for the fact that if you win the lottery, you also get financial aid, and that's exactly the effect we want to have. But except for that, the lottery itself should not influence financial aid. So this is an example of how to use the method of instrumental variables. Basically, we're doing it in 2 steps. First, we're using the instrument to predict the variable that we're interested in, like financial aid in this case. And second, we're putting that into the model, and we're using the predicted value instead of the actual value. And the coefficient we get on this is the unbiased or the true causal effect if everything else, if all the assumptions are okay, of course.